Hello, everyone. I hope everyone is still having a good day. And actually, tonight we're starting a whole new unit. Isn't that fun? I'm very excited for it. Uh, so, ooh. We are starting the unit of solutions. That's right, solutions, the answers. Now, in chemistry, a little bit of different. In chemistry, I should say reactions, many reactions. Many reactions are done underwater. And the reason that we do these underwater is because it kind of makes a more consistent environment, a more consistent surrounding, right? It has water happens to have very high heat capacity, so it doesn't change temperature that much. It keeps a constant pressure, right? The outer air pressure doesn't really affect the pressure in the water, and it's still movable like a liquid. That's why, or I should say, that's where we get the state of matter aqueous. It's the whole point of calling aqueous a different state of matter, liquid, solid, gas, aqueous. It's because we just kind of say that everything's done underwater. So let's do some definitions. Of course, we remember that solutions, or a solution, is not just an answer in chemistry. It is anything that is in solution is defined as dissolved into water, and because it's dissolved in water, it must be a homogeneous mixture. All solutions are homogeneous. And there are, for every solution, there are two parts. The first part is the solute. And the solute is the substance being dissolved. Whereas the solvent is the substance doing the dissolving. And really, for solutions, unless stated otherwise, all solvent in chemistry is going to be water. Most times, a solution solvent is water. Now, of course, when we talk about solutions, we have to talk about the most important property of solutions, solubility. Solubility. And solubility is the ability for a set amount of solute to be dissolved in a set amount of solvent. very important to note that solubility it's not how fast a solute dissolves. It has nothing to do with how quickly you can dissolve something. It all has to do with the amount of solute per amount of solvent. And when we talk about amount of solute per amount of solvent, that's what we call the concentration. So the concentration of a solution is the amount of solute per amount of solvent. Okay. And then when we talk about solubility, we know that if you have a cup of, say, salt, you can't dissolve that salt forever. There is a maximum amount of any solute that can be dissolved in a set amount of solvent. There's a maximum amount of salt that can be dissolved in 100 grams of water, right? And so we have different definitions for depending on if we've reached that point or not. And you probably have heard these definitions. First one is called a saturated solution. Now, saturated usually means full of water, but in this case, it's actually that the water is full of the solute. In other words, a saturated solution is a solution that has the maximum amount of solute dissolved. Whereas the unsaturated solution is not at the maximum amount of solute dissolved. Or I should say specifically less than. Maximum amount of solute dissolved. Much less. Okay. So we can reach that point of solubility, that point of saturation, or we can be less than it. Yes, a solution, a glass of water. I guess a glass of water would technically not be an unsaturated solution. And you're now going to tell me why. Thank you. So let's talk about some factors that impact the saturation point. And the first one, and when we say factors that impact the saturation point, this means specifically changing the amount of solute per solvent in a saturated solution. We could start changing the, let's say, changing the limit. It's really changing the saturation point, but changing the limit of solute that can be dissolved in the solvent. And the first factor, of course, is temperature. So a hotter solution a hotter water can dissolve more, for most things, can dissolve more salt. And the second is polarity. Polarity of solute and polarity of solvent. And we get a saying for this. That saying is like dissolves like. In other words, polar dissolves polar and non-polar dissolves non-polar. So water can dissolve salt because they're both polar substances. Water can't dissolve oil because oil is a non-polar substance. You need a emulsifier to help dissolve that oil into that water. An emulsifier actually is a giant molecule that technically the whole thing is polar, but really it has a giant end that's non-polar and a giant end that's polar, and it allows you to break kind of that polar non-polar barrier, kind of allows you to pull things into mixture. Right? It's hard to say that it's actually dissolved. I would say that technically when you put soap and water, you don't make a solution, you make a, actually it's called a emulsion. The difference between a solution and an emulsion is that, like everything else, it's a spectrum. And on one end of the spectrum, you have homogeneous, completely separated, heterogeneous, completely separated. On the other end, you have homogeneous, which is mixed down to the size of a very small molecule. And an emulsion is kind of 2/3 closer to, let's say, if this is homogeneous, this is heterogeneous. The emulsion is going to be somewhere around here-ish. It's clearly more mixed than not mixed, and this is all based on the size of the mixture. Homogeneous emulsions, the actual dissolved, the mixed up particles aren't dissolved on the molecular level. Anyways, I digress. Our final factor that impacts saturation point is pressure. But this is only for gaseous solutes. Okay. So I told you that solubility is all about amount, not about speed. When we talk about speed, we talk about the property or the idea of the rate of dissolution. The rate of which solution? Dissolution. Now, rate of dissolution. The rate of dissolution, this is the speed that a solute dissolves. And of course, factors that impact rate here, temperature, once again. So yes, hot water will be able to dissolve faster and dissolve more. That's kind of the in between. But there are other factors that only affect rate and not solubility. For example, surface area. Stirring increases surface area, right? It increases the surface area of the solute. So when you stir it up, that's why all that salt dissolves faster. Also, you know that if you try to dissolve a cube of sugar as opposed to a packet of sugar, the packet of sugar is going to dissolve much faster than the cube of sugar, right? Surface area of the solute. And we can also say state of matter. For example, a great example is that a solution will dissolve quickly into water. In other words, if you have 20 grams dissolved in water and you put that solution into more water, it will dissolve quicker than if you just put the solid 20 grams into that whole amount of water, the solid straight into the liquid. So solutions dissolve well into water, into liquids. Also, liquid solutes and gaseous solutes dissolve a lot faster than solid solutes. And of course, when we talk about rate, we always have to talk about a catalyst. Catalysts, there aren't many catalysts that really are specifically for dissolving things, but I'm sure there are some out there that technically make things faster. So I wanted to throw that there. And that is your introduction to solutions. Thank you so much for watching. I hope everyone has a wonderful rest of the day. Bye.